are the qualitative charts. And we have to monitor the qualitative variables, that is attributes and characteristics. What are the attribute and characteristics? They are briefly described in the previous lecture. So today's lecture are we will go through some classical examples so as to get to know about both P and C chart. So by examples we will learn that how to construct P and C charts, what are the control limits, upper control limit and the lower control limits, and if something is out of control, then how we can monitor it. So let's start with the P chart, which are the qualitative variables. P charts to analyze the proportion of non-conforming or defective items. So what proportion means, I will let you know in the example. It's the core thing of the mathematics, like in the secondary school and also in the intermediate level. Total number of defective divided by the total number of sampled. So we have to take this average formula, P bar. So please note down that it's basically in the numerator we have to take total number of defective, and in the denominator we have to take the total number of samples. The upper control limit is very much different. In this case, it's basically a formula. I will take my marker so that I will individualize the things that to be discussed. Okay. Sorry. So these are the individual terms in case of upper control limit, UCL. So P bar is from the previous slide, which is the total number of defectives divided by total number of sampled. This term will be from the previous calculation, whereas the remaining terms which have to be added in upper control limit are this, which is 3 multiplied by under root of P bar into Q bar divided by N bar. So what is Q bar and N bar, I will let you know in the next slides. So please know that here the 3 is not the cube root, but it's the number that has to be multiplied with the remaining terms. So the remaining terms are these ones, the under root of P bar multiplied by Q bar divided by N bar. So first we have to calculate P bar, then Q bar, we have to multiply both of them, and we have to divide it with the N bar. And at last we have to take the square root of the term, and then once we have the square root, then we will multiply it with the number 3. Once we done that, then we will add this term to the P bar, which is here. On day 1 we have taken, it's a process industry, assume there are produce so many items per day. Just take the example of some auto part manufacturing industry which produce let's say a gear. So it produces thousands of gears per day. So what we'll do, we take the sample of 200 gears, and out of these 200 gears for one day, we have noted that for day 1 the 11 gears are defective. So again in the second day, again we have taken the 200 samples, for they are 156, whereas divided by the total number of samples. So 200 is common in all the sample sizes from day 1 to day 15. So we have to add these 200 for 15 days. So the number is 3000. So we have to divide 156 by 3000, and number is 0.052. So P bar is now, we have calculated there Q bar is 1 minus P bar, so 1 minus 0.052, so Q bar is 0.948, whereas the N bar is the sample size, the sum of all the samples divided by number of um, days at which these samples are taken. So 3000 divided by 15 is equal to 200. So by this means we have calculated the N bar as well. So by this table, as you can see, the P bar is known, the Q bar is known, and N bar is known. Now we have to go for the control limits. So here are the control limits by the number of samples on each day. So 11 divided by 200, it will be 0.055, and by this means you will calculate your proportion for day 1 till day 50. So what you will do, you will add another column and name it proportion. So proportion is nothing but you have the non-conformers 10 plus 12, 13 plus 15 plus 9 till 12. The total number of non-conformers from day 1 to day 10 are 119. Whereas if we sum the samples from day 1, which is 2 to 4 till 165, which is day 10.
जो क्यूबा
फिर